Hey, welcome back. The Internet. You're on it right now. You've been on it all day. You probably can't go 2 hours without it. But here's a question that only a few people can answer. How does it work? Like you type a web address, hit enter, and half a second later, a full web page loads on your screen from a server sitting in a data center thousands of miles away. How? What just happened? It's not magic. It's not satellites beaming signals down from space. And it's actually way more fascinating than you think. By the end of this video, you'll genuinely understand what happens every single time you go online. Let's get into it. Before we trace that journey, we need to get one thing straight. What actually is the Internet? Here's the simplest way to think about it. The Internet is just a massive network of computers, all connected and all agreeing to speak the same language. That's it. Billions of devices, phones, laptops, servers, etc., all linked together and following a shared set of rules to swap information. Those rules are called protocols. Think of protocols like the rules of a conversation. You ask a question, I answer. I don't start talking in Mandarin if you're speaking English. The Internet's most important protocol is called TCP/IP. And it's the reason every device on Earth can talk to every other device, regardless of who made it or where it is. Now, here's where it gets interesting. That information traveling between devices doesn't move as one big chunk. It gets broken up into packets. Imagine you want to send a massive jigsaw puzzle to a friend across the country. You don't stuff the whole thing in one giant box. You break it into smaller boxes. Label each one. Box 1 of 10, Box 2 of 10, ship them separately, and your friend reassembles it on the other end. That is exactly what your data does. Every email you send, every YouTube video you stream, every Google search. It all gets broken into tiny pieces called packets. Each packet is labeled with where it's going, where it came from, and its sequence number so it can be reassembled correctly. Here's what's wild about this. Every single packet can take a different route to get to the destination. One might travel through New York, another through London, another through Singapore. They all arrive at the destination and get snapped back together in the right order in milliseconds. This system, called packet switching, was actually invented during the Cold War. The US military wanted a communication network that couldn't be knocked out by a single bomb. If one route goes down, packets just find another one. That resilience is baked into the Internet's DNA from day one. Now, here's the part that genuinely surprises most people. You probably think the Internet is mostly wireless. Wi-Fi, 4G, 5G. It feels like everything floats through the air. And yes, the last mile to your phone or laptop is wireless. But the backbone of the entire global Internet? It's physical cables. Mostly undersea cables sitting on the bottom of the ocean floor. Right now, there are over 600 undersea cables stretching more than 1.3 million kilometers across the world's oceans. They're about as thick as a garden hose. And they carry roughly 95% of all international Internet traffic. Every Netflix stream, every international video call, every cross-border bank transfer, almost all of it physically travels through cables on the seafloor. These cables carry data as pulses of light using fiber optic technology. Light travels through glass fibers at nearly the speed of light, which is why data can cross the Atlantic Ocean in about 60 milliseconds. Satellites do play a role, especially in remote areas, and newer low-orbit systems like Starlink are changing that story. But make no mistake, cables rule the Internet. Okay, so now let's put it all together. You open your browser and type google.com. What actually happens in that half a second? Step 1. DNS lookup. Your device doesn't understand google.com. Computers speak in numbers, not names. So your device asks a DNS server, basically the Internet's phone book, hey, what's the actual address for google.com? The DNS server replies with an IP address, something like 142.250.74.46. Now your device knows exactly where to go. Step 2. The request. Your device sends a request to Google's server at that IP address. That request breaks into packets, travels through your router, through your ISP's network, across physical cables, maybe across an ocean, and arrives at Google's data center. Step 3. The response. Google's server receives your request, grabs the right web page, breaks it into packets, and fires them all back to you. Those packets travel back across the network, reassemble on your device, and your browser renders them as the web page you see. All of that, the DNS lookup, the request, the response, the reassembly, happens in under a second. Honestly, the fact that it works as reliably as it does is one of the great engineering achievements in human history. Here's a question that catches everyone off guard. Who owns the internet? And the answer is nobody and everybody. There's no single company, government, or organization that owns or controls the whole internet. Different pieces are owned by different players. Internet service providers own the cables in your neighborhood. Tech companies like Google and Meta own their own private data centers and long-distance cables. ICANN, a nonprofit organization, manages the system of domain names. Governments regulate it within their borders, some more than others. The internet is less like a single highway system and more like millions of roads built by millions of different people, all agreeing to connect and use the same driving rules. It's a genuinely remarkable act of global cooperation that most of us take completely for granted. All right, let's put it all on the table. What is the internet? A global network of connected devices speaking the same set of rules, protocols. How does data travel? Broken into packets, routed across the network, reassembled at the destination. What carries it? Mostly physical undersea cables using fiber optic light pulses, not satellites. How does a web page load? DNS lookup finds the address. Your device sends a request. Server sends back packets. Your browser assembles the page. Who owns it? Nobody and everybody. It's a decentralized, cooperative system. That's your map of the internet. And there you have it. The internet, fully unpacked. The big thing to take away is that the internet isn't a mysterious cloud floating somewhere above us. It's a physical engineered system, cables under oceans, servers in data centers, packets flying across the globe, all built on a surprisingly simple idea. If we all agree on the same rules, we can all talk to each other. And that idea has connected billions of people and fundamentally changed what it means to be human in the modern world. Not bad for a bunch of cables and agreed upon rules. If you enjoyed this, smash that like button, subscribe, share, and I'll see you in the next one.